Okay, so now we talk about some of the most basics and very important thing, and we've been through it a little bit. All we're going to say is the same two. We're going to say the list, and then we're going to say one var stat. That's literally all we're going to say. We're going to take a little bit, deeper look into this though. But this is the video, so let's kind of start over with the basic description. Not too descriptive, but also not too, not skipping too much. So to do a list, I'm going to do a list on the left a little bit, so I'm writing stuff on the right. But we do the stat button right in the middle of the screen. This is a step-by-step thing. And then we just press enter because we're already where we need to be, which is on edit. So we just press enter there. And then we're at our lists. Yeah, you highlight a list, I don't know how to say highlight, HL. You scroll up, that's an up arrow with a little compass. Yeah, you scroll up and you highlight L1 and you press clear, enter if you want to clear a list, and that'll clear it. Yeah, so that's our little description there. Now typing into a list is pretty self-explanatory, but we have L1 and we're just typing everything in 28, 784 right down the line. So I'm doing this live here. I have to actually do it. We do that right on down the thing there. Yeah, let's kind of do it a little bit more there. We're going to talk about the 5-number summary also. In fact, let's just wait on that. Always get ahead of myself. Yeah, then second mode is quit. Second mode, what that actually is quit. And then we do stat again, the stat button. We scroll over to the right. That's a right arrow, just one to calc. And then we have to have one var stat. That's our thing, is one var stat. And we have to have in there L1 or whichever list we put everything in. And then calculate and then edit. So we do all of that and it gives us stuff. So the X bar, let's talk about the stuff. The X bar, that's the sample mean. Yeah, in which case we get 42.1. We see it right there. Yeah. So they didn't ask for everything here, but if you ever want to sum that list, this little sum of symbol, that's the sum. This one, the sample size n, it actually is important. Sample size n is the sum of that list. I didn't just say that. It gives us the sample size n is 11. This is not a frequency distribution. That's not, has no meaning to this one, but sometimes the sum has a meaning. Okay, so Sx and sample size is 11, that's there. Sx is the sample standard deviation. That's very important. That's the sample standard deviation, yeah. It's always sample. Very rarely is it population, but if it was population, sometimes you can have small populations because technically the population formula is a little bit different. S is this whole thing here. This is getting sidetracked here. But remember, sample standard deviation is the sum of all x minus x bars squared over n minus 1, the square root. Yeah, that's S. Population is literally the same thing, except it divides by n instead of n minus 1. That's the silliness there. That's sidetracked though, so don't worry about that. Okay, so that's basically it, except for the 5-number summary. The 5-number summary is the min, the Q1, the Q2. The Q2 is also the median. Median is Q2. The Q3 and the max. So the minimum value is the minimum, the max is the max. So these are percentiles. I think it's better we talk about this later. We're going to end up going through all this later. I just can't help but say it now. But 25% of our data is underneath Q1. 50% of our data is underneath Q2 or the median, yeah? The median is literally the middle value. 75% of our data is below Q3. So that's basically what the 5-number summary is. So if we go through this thing, One var stat gives us the mean. One var stat gives us the median, which is Q2. So a mode is just the number that occurs most. It can be bimodal, trimodal. If you have like a number that occurs 3 times and another one that occurs 3 times, all of them in a mode. Okay, so the mid-range, they ask us a few strange things that are, I wouldn't say unimportant, but they're not nearly as important as the other stuff. But they can even ask more than the mid-range. But if they ask for the mid-range or anything, it's literally just a formula. Yes, so we said the min and the max, didn't we? The mid-range is literally just the minimum. Yeah, the minimum value plus the maximum value divided by 2. And it's not a range, the mid-range. What is the min plus the max divided by 2? It's more of a center of the thing, kind of like the median, but it's not the median. Yeah. So the mid-range, what meaning does it have? It's always hard to give it meaning. We don't really care that much what meaning the mid-range has, but it's the min plus the max divided by 2. Yep, and we said this before, Jersey numbers are nominal, and calculating this statistics for that is meaningless. What do we basically have when we do a one var stat? Yeah. What do we basically have when we do a one var stat over here? We have measures of center, on topic, off topic, I never know. But this is the basic thing, measures of center, and we have measures of spread. Yeah, there's 3 main ones for measures of center: mean, median, and mode. That's all we care about, mean, median, and mode. I think the mid-range, even though we don't care about that, mid-range is also a measure of center. There's only 2 of them with spread. There's the range, which we didn't do here. The range equals the max minus the min is the range. So the range is a measure of spread, and the standard deviation is a measure of spread. Those are the main ones there. So bigger numbers, but this is the exact same question. What would I do with that? And we're going to get into Stack Crunch a little bit, right? We're going to get into Stack Crunch a little bit also. So I don't want to do Stack Crunch in this video. I might do like a full Stack Crunch is like a very mini. It's not anywhere near advanced as Excel, but Stack Crunch is kind of like a tiny mini Excel where there's more functions in there than we can ever cover. But we can very thoroughly, systematically cover a lot of the basic functions. Yes, we don't want to do it now, but I literally put this in the TA84, and if that takes too much time, which for this one it would, then we put it in Stack Crunch, but it's more or less the same. We just put it in a one var stat over in Stack Crunch, yeah. Okay, so this is GPA. This is a new definition. Yeah, we have mean. Yeah, this is the formal. I know that this is not mean, this is weighted mean, but we didn't talk about the equation for mean. This is the formal equation for mean. Yeah, the mean equals, it is the sum of all x values divided by the number of x values. Number of x values is sample size n, and the sum of all x values is that. So that's the actual way to write the equation. We wrote this before. We don't care about variance. Variance is standard deviation squared. But what is variance? It's the sum. And there is more than one formation of the formula, but this is the common one. If you take all the x values, you subtract off the mean, you square those, and that's a value. You sum that column, and it's the sum of all x minus x bar quantity squared. This is one number. Some people look at that, and it does not compute in their head as one number. But that whole thing is one number. So if you take that number, divide by n minus 1, that's the variance. So that is variance, which we don't want. We want standard deviation. What do? We take the square root of both sides, and we have s equals the sum of all x minus x barred squared over n minus 1. Always sample standard deviation, the square root. And this right here is our standard deviation formula. Sometimes they still enforce it. We're supposed to know this, and I never forget it. But you don't ever need it because one var stat will give you that thing right there. Okay, so what did I do here just for fun? That's the mean formula. This is the sample standard deviation formula, neither of which we need for this problem. For this problem, we need the weighted mean formula. All that just popped into my head when I saw the weighted mean. So the weighted mean has weights. It's like the sum of all, I don't want to write the wrong formula. There is a way to write the weighted mean formula, but we don't need it. We just want to kind of remember, because you have like, I don't know if a weight is like a frequency. This is one where we have an L1 and L2. We might multiply straight across to have an L1 times L2, and then we sum that. Let me just quick kind of Google the formula right here. Okay, so this is a good one. So a weighted mean, this is a weighted mean, is the sum of all x times the weights divided by the sum of all weights. That's what it is. This is kind of like the sum of all x, and this is kind of like n. But it's the sum of all x's times weights divided by the weights, yeah? So let's see if we can do this. If we have an L1 and an L2 in our calculator, yeah, so we have the credit hours, which is 4, 4, 4, 3, and 1. Yeah, and we have the other one. We have the grades, which are A, B, B, C, D, but we have to know the things there. That's 4, 3, 3, 2, yeah, 1. That's A, B, B, C, D, yeah. So we literally multiply straight across, yeah, and we get 16, 12, 12, yeah, 6, and 1. And if we add that column there. So that's what's puzzling about this. Which one is the weights? Yeah, the sum of all weights. We have the credit hours. Yeah, the grades are going to be the weights. So this one is going to be the weights right here. I made a mistake there. This one is the weights, yeah. So it's hard to determine which one is the weights. But I think the credit hours are going to be the weights. Yes, we have these grades, and it's like we have 4 A's. It's like we have 4 B's. It's like we have 4 of those B's. It's like we have 3 of those, but it's always very, very hard to determine which one is the weights. Yeah, I kind of wrote them backwards there too. But if we do the sum of those, see if I did this right, because I have the sum of the multiplication of them. The sum of that is 47. And then the sum of the weights, yeah, the sum of that is 16. I got 47 divided by 16. I got 2.94, which is what I got the last time. Okay, good. Yeah, so just for reference, when we kind of do this, yeah, the grades are going to be the x values. Those are the x values, and the hours are always going to be the weights. The hours or the units or whatever they call that, it can vary. But weighted mean is a little bit harder to do. 2 Okay, so this is kind of the same thing. This is like a frequency distribution. Boy, this requires like an entire new lecture here. Okay, so where are we leaving off at? We're leaving off at number 22.